So it's a pleasure today to talk about predicting frailty condition in elderly using a socioclinical database. This is a joint work with several people. The first two are from the Department of Computer Science Engineering, like me, and they have database background, like me. The last three instead are medical doctors. They work either as academics, like Giulio Marchesini at the School of Medicine, or Giacomo Veronesi is from the Guarda Hospital. Well, the most important person here is Paolo Pandolfi, the guy who gave us the data. He's the head of the epidemiological unit for the Bologna area. So let me skip the outline. We know that life expectancy is increasing worldwide. This is a chart that was popular a few years ago. Essentially, it says that from 2000 to 2030, the number of elderly, or if you want, subjects with more than 60 years old have more than double. Actually, they are 2.5 times. So combined with the fact that we have less children born, in Italy we have one of the lowest natality rate, it is 1.1 per woman. We have a good combination for an epidemic of aging. So with a longer life, it also comes higher cost. Here you find some data from United States, where maybe economic data are more accurate since they have an insurance system, a private insurance system. So that's the Medicare expense. 1/3 goes to the people aged more than 80, 30% in the court, 70, 79, and the rest to everybody else. What is frailty? Frailty is typically an age-related condition. Its concept has emerged, but it's not a well-defined identity. Somehow, there are different methods that you can find in literature to determine the frailty state. So, roughly, there are two classes of approaches. One is a hard line, where you take in consideration only clinical and biological feature, like you have a specific disease, chronic disease. Another group where you take into account softer disease, like things like depression or cognitive impairment. And the third one where you consider all the factors coming from this domain that are the clinical, the psychological, the cognitive, and the psychosocial. So we rely on literature to define frailty. So we take the definition that has been given a few years ago at the end of this research that was supported by the King's Fund. And so essentially the definition we will see is the risk, if you want, the probability of an emergency hospitalization or death within a year. So in this context, we propose two different models. One model is called the frailty risk model, that essentially assigns a score to each subject, or if you want, each person older than 65 years, and identify 5 different classes for tailor-made intervention. Here they are depicted with color. So the class which is green, there are people that are no frail at all, and then you have different level of pre-frailty until you reach the last class where there are the frail. By the way, this score that we assign goes between 0 and 100 and actually measure the probability. So 100, you have a probability 100%, 50, you have probability 50%. And actually, we use as a data sources, we'll see more details in the next slide, 3 different set of databases, one with personal data, another one with social data, and the third one with health data. And all these databases we'll see are not under the supervision of the same authority. Some of them are attached to the local health authority, some other are linked to the municipality, some other are nationwide. So we say that we want to build 2 models. One is the frailty risk model, and the second one is the worsening risk model that also assigns a score to each subject, each person, that actually belong to the green class. And this score measures the probability that somebody in the green class will either move to the yellowish class, pre-frail 1, or to the orangish class, pre-frail 2, or 3, or frail, okay? So we'll give an indication of how people are increasingly becoming frail. By the way, the whole study can be found, just being published in the Proceedings of IEEE, the journal. So why do we think the outcome of these models are important? Because, as we said, emergency hospitalization or all-cause mortality within a year are used as a surrogate for frailty. And the model is able to identify and classify the elderly ages 65 and above according to a frailty and worsening risk index. Yesterday we heard from, I think, Peter, the stratification of patient. Here we are trying to stratify elderly, if you want, okay? So the classification provides some advantages. Since we cannot do much about aging, we will all age, or we are all aging. The first advantage is the possibility to deploy early prevention countermeasure before the manifestation of the total non-self-sufficiency. Actually, this is the strongest point, and it's not by chance that the people that appear more interested in this study are insurance more than anybody else, okay? The second point is define new model of integrated personalized, not medicine, but social healthcare assistance, and new modular services about specific risk level. Since the resources are scarce, we will need at some point to decide what we want to give to whom. And so the third advantage, which is a combination of the previous one, try to mitigate the increasing health costs for the aging population, and generally for the elderly people. So this is what usually people in computer science do in this case. This is known as a data warehouse. Yesterday, I heard this discussion about databases, data warehouse, why we should make a copy of data if data is already there. Usually here on the left, you find the sources that before depicted as 3 cylinders. In practice, there are 12 different, let's call it database. They are known as a registry. Some of these registry are in the capacity, let's say, of the municipality, like the debt registry, or the civil registry are in the municipality, in this case of the city of Bologna. Other things like hospital discharge record, depends from the hospital where you are at the moment. Other things like medical exemption certificate registry, we will see essentially a registry where if you have a serious condition, like you have a cancer to a kidney, actually you enter into this registry and you get exemption for 5 years, and this exemption can be renewed. It means you will not pay for blood test, any treatment, surgery, chemotherapy, or whatever will be needed, okay? There are other registries we'll see shortly, but and then in the data warehouse usually you get these funny things like ATL, extraction, transformation, loading. Together with previous year sample, we see that we have a number of years of this data. And then before to build the what is called the sometimes in literature you find this to be known as the data warehouse. Here it's called data cube. We use 3 different, let's say, other components. One, ICD-9-CM taxonomy, because at the end of when you have a diagnosis, you need to figure out exactly what this diagnosis is about. It's about cancer, it's about dementia, or heart failure, or whatever. And we know that ICD-9-CM is very useful. Now there is a transition to 10, but still we have a lot of years of data with 9. Plus, we have a drug database. This is held by the National Pharmaceutical Agency. So again, it's drugs that you can get if you live in Italy. And then there is this exemption database where we store in some other form people that do get exemption for previous pathology that they had in the past. So this is the overall architecture of a data warehouse where, let me stress again that data are copied in this data cube after they are somehow reconciliated. These are known as the operational database where you perform transactions, you insert things, you remove things, okay? You don't want really to touch. Then nobody will allow you to touch this. They will kill you. So you may wonder how much data has been involved here. Well, as we said, we started with this 12 databases that contains tens of thousands of variables, if you want, columns of tables. Let's have a look at some of these databases. As we said, if you live in Italy, the civil registry is done by the municipality, so even if you're born in a hospital, then the admin process will go to the municipality and say that you're born in that city, okay? So let's say you're born in Bologna and then you die in Milan. So you die in Milan, there will be a doctor signing a piece of paper and passing this to the municipality of Milan, that then will pass to Bologna and close. So check in and check out, these are under constitution attached to the municipality in Italy. And then you have other registry like health registry where we record all the, let's say, outcome of that you could have with your general practitioner or with other specialists. Then we have, for instance, what we call hospital pharmaceutical registry. This is a special registry where if you have, let's say, kidney cancer, they give you special drugs. Even when you get out from the hospital, you don't buy from the pharmacy, but you get directly from the hospital. Instead, if you use a traditional pharmacy, we have another registry called the territorial pharmaceutical registry, where your GP prescribes something, you go to the pharmacy, you buy it, and then it goes into this other registry. Then we have other things like public home health care registry, which say everything on its own. What else? Emergency department registry. When you check in into emergency department, you enter in there, and there is one obviously for each hospital, and so on and so forth. So out of this collection of databases, we started with 50 different variables, according to the literature that I was mentioning before. And we use different models for predicting this frailty condition. In the full paper, you find 5 different models that we tested, we compare. I can give you the outcome. At the end, we have chosen the logistic regression that was the most, let's say, the most accurate model. And this logistic regression has somehow helped to extract the most meaningful variable. These 27 variables for the first model, the frailty risk model, and 26 for the worsening risk model. The variable missing is this one with the star. Let's have a quick look at these variables. So there are personal data like age, gender, nationality, housing condition, you rent, you own, you live in social housing, or you share, the level of education, income. Income, we do not have a precise value. We use the tax system that is based on different bands. And then if you are married, hospitalization, let's say emergency room visit, or diagnostic test, or the blood test, or the scan that you had, and so on and so forth. Let me jump a bit. Cancer, here that's variable 0, 1. You had the cancer, 1. You don't, 0. Any cancer, any time, any point of time in your life. Then other things, maybe the other thing that I want to underline is dementia. Dementia, again, you have, you don't, but it's very difficult in the Italian system that you get as a diagnosis dementia. Usually we spotted dementia looking at the principle of special drugs that can be given only to people with dementia. And we discovered that doctors, even neurologists, are inclined not to say this person has dementia, but they give the drugs as if he or she would have it. So what we've done essentially is a retrospective cohort study that we conducted on the whole elderly population of the municipality of Bologna. Bologna at that time in 2010 had about 300,000 residents. The over 65 were about 26,000. So we created a baseline cohort of 95,000 subjects from 2009 to 2010 for the frailty risk model, and the new independent baseline cohort of 58,000 subjects from 2011 to 2012 for the worsening risk model. And then we applied a number of filters to clean the data, because we want that this cohort were somehow very clean, so we removed everybody who died in this period, everybody who emigrated, became non-resident, and so on and so forth. So this cohort has been divided in training set and test set, 2/3, 1/3. The test set to evaluate the model. So here is what we have done somehow for the frailty risk model. We use the year 2009 and 2010. This cohort, as we said, 1/3 for test set and 2/3 for training set. We compute the X and beta that we will not see in this presentation, but they are in the paper. And then the follow-up years were 2011 onward, and we started the evaluation. We believe that this model should run for at least 20 years, since the average life expectancy in Italy is 80-something. So if you enter into this process when you are above 65, you cannot really expect something good for at least 20 years, okay? So this is the frailty risk for the 6-year follow-up. Here we have these risk classes. We say non-frailty, by the way, is 0 to 14, or the pre-frail one is 15 to 29, and so on and so forth, and the frail class starts from 80. So here it means that in 2010 we have 65 people, 104,000 people over 65, and then actually these were the number of events that occurred, 5,256. It means that it could be the same person that had 2 events. Maybe once he had an emergency hospitalization, and then 2 months later he died. So, and then into rounded bracket you get the percentage in each class. So as you see, the percentage of 7.5 plus or minus 0.2 are well within the range of non-frailty, or here is within the range of pre-frail 1 and so on. We only had, if you look at the last class, the frail, you see that we have a percentage that is 74.4 plus or minus 4.7%, and actually the class should be from 80 to 100. So it means that the model is overestimating the number of events occurring in the frailty class, but this is considered an advantage. We don't want to have false negative, although we accept some false positive. And so since the number of events that occurred are few hundred, these have been all manually checked by the admin people in the epidemiological unit, and we know that nobody was left out. So we predicted more events that actually happened, as this percentage is showing, but we do not have false negative. So for the worsening risk model, we have used as a cohort 2011, 2012. That's the people, the number of subjects, 2/3 for test, 1/3 for 2/3 for training, 1/3 for test, and then the evaluation has been done for from 2013 onward. We have somehow a similar result, although here we do not have any somehow overestimates. Essentially, these are the non-frail person in 2012. So when you apply the model, you apply to the old set. We haven't done then the cleaning that was done for training and testing purpose in the first 2 years. And then actually again we have the persons or the percentage that move in a higher frailty class in 2013. So there are people obviously that are moving in a higher class for mainly 2 reasons. One, they get older, and the second one is that sometimes they die for even other causes. So let me conclude saying that this model has been tuned for the Bologna city, can be extended to other cities or maybe internationally, adjusting obviously for the different conditions. And finally, there is an online experimental calculator for frailty risk model only. If you want to use it, you are welcome, but keep in mind that it's tuned on the Italian population. Okay, thank you so much. Sorry for the time.
Questions from the floor?
Yeah.
So logistic regression looks at a binary outcome usually. Is that what you're doing?
Yeah, yeah.
So your binary outcome was either hospitalization or death?
No, the event that we're measuring is that if you had emergency hospitalization or death. Yes, but it was oral. Yeah.
In terms of Frailty index, was there an intervention that could be instigated that could prevent deterioration?
Well, let me jump forward. I didn't mention those things like these are somehow the odds ratio of the variables, so the importance of variables to the final score. So if you look, there is the age, which, logistic regression work better with non-continuous variables. So we decide to divide the age in segments. Obviously, when you are above 91, that is the most important variable, and then, the other, the age. But for instance, we got some glimpse, for instance, the family income, if you see less than 15,000 euros, and if you look at the other ranges, it's obvious that the income has less weight, but it's still important. The other element is that we notice if you are a couple, if the man would die, the life of the woman will increase, but not on the other way around. If the woman would die, the man, the remaining will, the expectancy of life will decrease. But it's still partial because we have few years of data. Okay.